Okay, guys, we're going to have our test on exponential equations and exponential functions this week. So let's do a little review. This question here says, a car purchased for $12,000 loses 6% of its value each year. So the first thing we're going to do is write an equation to model this situation where x is years and y is the value of the car. And we're going to try to figure out what the y-intercept would be and what does that represent, and then how much is the car worth after 10 years. Okay, so with exponential growth, there's two formulas we're going to use. If in the case of exponential growth, the formula is y equals, let's say, a times 1 plus the rate to the power of x, or to the power of t for time. And in the case of exponential decay, we're going to have y equals a, that's the starting amount, times 1 minus the rate, that's how much you're losing every year, to the power of x. And because this one is losing value, we're going to use this equation here. So let's think about a couple things before I write out the equation. So y is going to be the value of the car. A is going to be the starting amount. So what should the starting amount in this equation be here? Let me do this in a different color so we know that it's going to be our actual answer. What should the starting value here be here? In this case, the starting value should be $12,000 because that's how much the car costs when we buy it. And then if it's losing 6% per year, so we're going to be multiplying by 1 minus the rate, and the rate is 6%. So how would you write that out? I'm thinking as a decimal. If you lose 6% of the value every year, so we're doing 1 minus 6% as a decimal, what should the factor that we're multiplying by every year be? Well, if you lose 6%, that means you're going to keep 0.94% of the value of the car. And then we're going to raise that to the power of x. So that's our equation. That's for part A. This is our answer to part A. Now for part B, if you were to graph this situation, what would the y-intercept be and what does the value represent? So I'm actually not going to graph this one, but I might draw a little graph over here just so we can think about what it would look like. So, okay, there's your y-axis, and there's your x-axis. So this is x and this is y. This isn't really a graph, this is just a little sketch of it. And our graph is decay, so it's going to go down. It's going to look, well, it actually never touches the x-axis. It has an asymptote here, so it's going to look kind of like that. But it crosses the y-axis here. And it's helpful to think that whenever we find the y-intercept is actually the line x equals 0. So we want to find out what the value of this function is going to be when x equals 0. So take a minute and think. What would happen if you plug in 0 for x? What value would you get out? So if you plug in 0 for x, I'll write it out, but it's actually, you don't even need to write it out when you think about it. Because no matter what our base is, any number, except for 0, any number to the power of 0 is 1. So it's really just 12,000 times 1, which is 12,000. So the y-intercept is going to be the point 0. Sorry about that. The y value is going to be the value 0, 12,000. And what does that represent? That represents the value of the car when you buy it. It's like at year 0. So that's like when you start. You're starting at 0. Whenever you buy the car is worth $12,000. And then finally, how much is the car worth after 10 years? So same thing, we're going to do y equals 12,000 times 0.94. Now it's to the power of 10 because we waited 10 years. So how much is this car going to be worth after 10 years? So I got to go over to my calculator here because that's too hard. Times, I'm just going to write 0.94. It's the same thing as 0.94 to the power of 10. And how much is the car worth after 10 years? $6,463.38. So when I see a number like this, because we're dealing with dollars and cents, we're going to round to two decimal places, and it's 3.8. You look at the one after the second decimal, which is 1, and that's smaller than 5, so we're going to round down. So it's our answer is the car is worth. Uh-oh, my cat just knocked something over. 6,463 dot 38 and 38 cents. Okay, let's take a look at a problem like this where you're given a chart, and what I want you guys to do is come up with an exponential equation that models this situation. So this chart represents the number of people who are infected with some disease. X represents the number of days, and then Y represents the number of people who are infected with the disease in that given number of days. So just like the last problem, we're going to use a very similar formula. It's going to be in the format of Y equals A times B to the power of X. And A is going to be our starting value, and B is going to be the ratio, the number we multiply by every time period. In this case, it's days. So my first question for you is, what's the starting value? In this case, because when days are 0, whenever we start counting from, there's already 5 people infected. So our starting value is going to be 5. So then the next question, and actually the last question, is what's the ratio? Meaning, what number are we multiplying by every time period? And in this case, to go from 5 to 15, we multiply by 3. To go from 15 to 45, we multiply by 3. And from 45 to 135, we multiply by 3. So the common ratio you're multiplying by is 3 to the power of X. Okay, that's our equation. And I actually said that was going to be the last question, but I lied. One more question. So how many people will be infected, let's say, after 10 days? Okay, so how many people are going to be infected with this disease after 10 days? Well, since X represents the days, all you have to do is go over to your calculator and use this equation, 5, and then in parentheses 3, to the power of 10, because we want 10 days. And it turns out that after 10 days, wow, that's a lot of people. Something like, oh, I can't see my calculator, hold on. 295,245 people will be infected after 10 days. And in this problem, we're looking at a graph of an exponential function, and we want to try to come up with an equation of it. So I guess the first thing I'll ask is, just by looking at it, do you think this is an example of exponential growth or exponential decay? And we can see that the graph is going down, so that means that it's exponential decay. So what can that tell you about the base of the exponent in this equation? Because it's going down, that means you're multiplying by a number that's less than 1. Specifically, it's between 0 and 1. So we know that we're going to be multiplying by a number between 0 and 1. And then we need to figure out what that number is. We also need to figure out what the starting value is. So I'm going to go over here to the graph where we have an x value of 0. Those are x values down here, and our y value of 0. So what am I saying? X value of 0 and a y value of 8. So that means that our starting value is going to be 8. So the equation is going to be something along the lines of y equals 8 times some base to the power of x. So now we got to think, like, what number are we multiplying by each time? When we go from x value of 0 to 1, our y value goes from 8 to 4. And then when we go again from 1 to 2, now our y value goes down to 2. So what number are we multiplying by to go from 8 to 4 and then from 4 to 2? So we have to be multiplying by a half. And so every time x goes up by 1, we multiply it by a half, and our exponent is x. This means every time x goes up by 1, we multiply by a half another time. And you can check this. Plug in 0. So if you had 8 times 1/2 to the 0, well, any number to the 0 power is just 1. So this is 8 times 1, which is 8, which means that the point 0, 8 is on the graph. Now let's try to plug in 2. So following this equation would be 8 times 1/2 to the power of 2. Well, a half times a half is a quarter, so that's 8 times 1/4, and 1/4 of 8 is just 2. So that means that it has the point 1, 2 on this graph. So in any event, this is our equation right here. Y equals 8 times 1/2 to the power of x.